Welcome back to the High Tech Forum podcast. Today we have an old friend joining us, Tews, of American Enterprise Institute, and we are going to talk about Spectrum. Hi, Shane.
Hey, Richard, it's great to see you.
Yeah, it's been a long time.
Yeah.
Is everything going okay in DC these days?
Everyone's still here.
Well, so the same old, same
Very
old.
busy.
Yeah, there's been a lot of activity around Spectrum with congressional hearings on various aspects of the Spectrum pipeline and trying to establish American leadership in 6G and security issues, a lot of related stuff. So I guess things. It seems like it must be pretty busy.
Well, when we first started talking about this several years ago, you were just explaining to me all the cool things that 5G was going to enable, and now we're getting to the point where it's happening, or it feels
Hmm.
like it's happening. So, give us some ideas on some of the use cases that you think are the first ones to come online.
Well, I think the general idea for 5G was going to be to enable Internet of Things, and so because there have been predictions for a long time that the most um, rapidly growing category of applications is machine-to-machine communications, which is part of IoT. And there's especially an awful lot of interest in the use of 5G on factory floors. And one of the one of the cool things about it, as we've seen in the last couple of years, there's been an increasing emphasis on video conferencing, which wasn't really anticipated, right, when the 5G
Right.
design foundational work was being done. It's just something that kind of happened. And in a way, I was happy to see it because I've been a big booster of video conferencing for a very long time. When I was in Silicon Valley, I actually had the pleasure of working at Compression Labs for a while, and it was one of the pioneering companies in video conferencing. And that was back in the days when, in order to get a video conference to work, you needed a really specialized piece of equipment that had like 17 different processors that were dedicated to doing different parts of the job. It cost an enormous amount of money, and of course, high bandwidth communication was. This is before the internet, so you couldn't assume that people had megabits of capacity at every drop. And in fact, the system had to work pretty well in 384 kilobits per second standard definition. So really not wasn't really all that difficult. So yeah, I mean now everybody's a video conferencing expert, and one thing that has come up that seemed like it was sort of a iffy proposition as to whether it would take off is the use of fixed wireless access as a residential internet connection technology, and that is really seems to be taking off right now in a fairly big way. With all the three major carriers making major investments in that. And it looks like if this dish network ever reaches maturity, it'll probably be part of that business proposition as well. And
That's
they're facing unanticipated competition from Starlink, which is something that I never really thought would be all that practical, but it turns out that in most instances it works. It works pretty well. Now the machine to machine stuff, which was actually the primary focus, that's been a heavier lift just because you have to create the demand side and the supply side together before that really works. And so we're starting to see people building customized 5G networks in factories. And but that's just starting to take off. You obviously have to have the robotic equipment and the sensors in the factories for that to happen, and we're seeing that now.
it seems like that would be much more efficient. But it is interesting to see, as we know, all the little devices need to be able to talk to each other. And I know when I talk to policymakers, everyone thinks that it's about people. And you're right, it
Hmm.
is about the machines being smarter and being able to do, more amazing things seamlessly and with less friction and faster.
Yeah, I mean it's just automation, and so when you when you have a manufacturing process in place that's designed around assembly lines and human workers, it's hard to automate it unless you replace components of that with that are done by humans or not done at all with you replace those with machines. And sometimes that actually means you have to redesign the product that you're making to make it manufacturable by the current generation of manufacturing automation equipment of robots, basically. And that takes some time. I know there was one of the big steps forward in that was that IBM used to have a mainframe computer terminal called the 3270 that was pretty much built by hand. And it took off to such an extent that they really had to automate their production just to keep up with demand. But in order to make it manufacturable, they had to redesign it to where it had a bunch of snap together components. There weren't as many screws that had to be, hand tightened and all that. And that took some time, but now, I mean, it's like nobody would even think of making well, people don't make computer terminals anymore, but I mean, as much. But, it's all kind of part of the gig. So it's like you got to solve about three different equations at the same time in order to automate the factory floor.
Well, and the software, which we, as Mark Andreessen a long time ago said was going to eat the world, we're definitely seeing just the ability for software, just giving so much more interest in having the capacity on the network to be able to
Mm.
do that, especially apps.
Oh, yeah. And one of the benefits of that, especially in the manufacturing context, is that when you have a software driven manufacturing system, and you want to reconfigure it to make a different product in the factory that you've set up to make, say, thing A, you want to make thing B. It's just a matter of swapping out the software to largely to reconfigure the factory. One of the interesting developments in that is that gigafactory that Elon Musk is building in Austin. That's supposed to be the most highly automated automobile manufacturing system ever built, and which is it's kind of Musk and Tesla go from being essentially manufactured by hand, 19th century style, to a real 21st century manufacturing process. And obviously, that's the kind of thing where you're going to need an awful lot of network capability inside the factory to make it work right. And yeah, he can probably do it as long as there aren't too many bots.
Is that a little ding at Twitter?
I
Well,
just don't think I've really been having a blast listening to all this speculation about what's going to happen when Musk takes over Twitter because it assumes that he actually will.
right.
And there's so much that has to happen to get from where we are today to a situation where Musk is actually running Twitter on a day-to-day basis. And I just can't see him having the patience to do that. It's not in any way like any of the businesses that he's run, pretty successfully.
So
But yeah,
I'm reading the book The Founders. It's about him and Peter Thiel and the whole early team that created,
oh, the
PayPal.
PayPal mafia.
Yeah, but it's even, before those two joined forces. And there's so many things he's trying to solve for in 1998 in the banking industry, which are so interesting because so many of them are still a problem today. And he was not wrong back then.
Mm-hmm.
All these regulatory burdens. And I think it's been fascinating to see how he was able to break in faster in the transportation and in the space race than he is in banking. But we're going to get in there. I mean, slowly, but it's been really interesting to watch that happen. I think going back to the Tesla and the auto manufacturing, I think it's also really interesting for people to have this ability to have things upgrade in the middle of the night in their driveway or wherever their car is, because
Oh yeah, yeah, yeah.
that's game changing. I don't have
Mm-hmm.
that in my car and I wish I did. It's just, the whole idea, like I'm going to the dealership and trying to get them to put the next version on my, audio system or my GPS. And we're gonna have an issue with that with when
Yeah,
3G goes offline, and we have a lot of cars that's how they're getting. My car does not have CarPlay, so I'm
yeah,
still
yeah.
in the car system.
Yeah, well, mine's 1 year too old for that. But yeah, I mean, just basic things like keeping your if you have a navigation system in your car, which I mean, I had to buy one because there were some other features I wanted, and I don't like the idea of buying a navigation system that I don't have any control over. How do you upgrade the maps?
Yeah.
And if you have a Subaru that you really can't. I mean, you're kind of stuck with whatever maps that you was in it when you bought it. And they tried to do some kind of thing that connects to OnStar and gets map data that way, but it's not secure. And so it's like it's a good thing I don't rely on that navigation system. I mean, I just use the one on my phone.
As I think has happened is, for those of us that have seen that migration where originally, Ford was trying to do a deal with Microsoft, and then there were all these other things where they were trying to do the pairing, and then they realized they were pairing at the wrong side of that equation, right? And that's once you started doing it on the
Mm-hmm.
device, and you didn't have to necessarily choose a team when you bought a car. Uh,
Mm-hmm.
and I just think, a lot of them are probably doing it. Tesla's doing the best job of letting people, very vocal about it, and it's really interesting.
I've actually had dreams where my car had CarPlay.
I'm kind of thinking you need better dreams, but I think that's adorable.
Well, I mean, it's not as common as the one where it's the final exam dream or the airport dream, but it's one. Yeah, it does. It has it has come up.
Yeah. I mean, I've been taking this class all semester, and I just found out I have to take a test. Didn't even know I was in that class, right? Like everybody else.
Yeah, yeah, yeah.
So
So,
are
and
you
it turns out that back to the manufacturing theme that was looking at Cisco's forecasts about the growth in internet traffic and how it's distributed. Uh, it's a couple of years old now, but they were predicting that the fastest mobile um, device category would be machine to machine, followed by smartphones. And that I don't know that that is actually reflected in the data, but it seems to be where if it's not true today, it'll be true in the next couple of years.
well, that's part of the seamless, frictionless part that we love about the way machines work and the internet works, but we just don't ever see it. So I feel like it's an
Hmm.
unsung hero.
Yeah, and I think they say that there's something like an average of every consumer has an average of something like 4 or 5 devices in their home that are network connected. And I wish I only had that many. I
Yeah, same
have
way.
I have a hard time changing anything in my home office network because I've got like 80 devices. Um, but
Well, let's go
one of
back to
the
the
thing,
fixed.
what?
Let's go back to the fixed wireless because I'm curious, being originally from Nebraska and being living now on the East Coast where it's easier to wire things when you're in the middle of the city. But we have a lot of the United States as we look at what's been going on with all the broadband spectrum use, and we've got the Congress now getting very dictatorial about how and what technology they want used, which I'm never a fan of. And they seem
Hmm.
to be very kind of hell bent on wanting a lot of wire everywhere. But the fixed wireless for so much of things, especially west of the Mississippi, and probably a lot of cases in other places too, seems to be a really good answer.
Hmm. Well, it actually works in cities pretty well too because there are a lot of cities where the ducts that carry the wires were sized, for like one telephone line per office building, right? And so a lot of those are just jammed, and so the you can't really install fiber in those unless you rip the copper out, first. It's already in there, so it can actually be a pretty major problem just to wire up even a place that has conduits and ducts because if they've been there for any length of time.
Well, that's
But
interesting.
in I think the real benefit of it though for the carriers is the fact that you can get another competitor into the market without having to spend as much in infrastructure as you would if you had to pull your own wire to every home. And
Yep.
so T-Mobile, they found themselves with an awful lot of mid-band spectrum, so they were able to offer a good fixed wireless access solution and have been for quite some time. And AT&T and T and Verizon have been able to get in the game since the C-band auction. Um, and it's just so much easier they take to leverage the infrastructure they built for mobile and do fixed with it because the mobile is the harder engineering problem. So, and once you've got that in place, then connecting up homes and offices in fixed locations is a snap. And this I tested one of those things out. I live in a pretty challenging area in terms of topography, It's real hilly. It's hilly, and we have a lot of trees. And so the wireless coverage tends to vary a lot. And so when I tried the T-Mobile thing, I got like 50 megabits per second down and about 20 up, which is, yeah, it's respectable. Um, it's funny that, that sounds like, poor folks hook up now, but there's really not very many things that a person might ever want to do that they can't do with a good solid 50 megabits per second.
Yep.
So yeah, it works okay.
Well, it's also interesting when you're looking at where they want to spend money and how they're not including a lot of the, mobile overlay plan as saying it's a served area. And I'm,
Mm.
that seems like that should change when you have answers like fixed wireless access that'll bring a lot
Well,
more.
yeah, Congress is still up to its old tricks in terms of, what they consider served. That it's got to be, I mean, in some cases it has to be symmetrical, in some cases it has to be fiber, and other cases they just, lay out the numbers and say as long as it meets the, technical requirements, you're okay. But yeah, there's, in that typical sort of interest group driven policy. It's like you're getting a lot of sun there, huh?
I know. I'm just it's it's
Probably.
it's a time of day or that I
Mm.
hear. But so the other
Yours
thing
is well, like if you were driving, you'd have your visor down.
which I would, that's what I'm using my hands for. The spectrum pipeline is getting very interesting too. First of all, that there is the chance that the FCC needs to renew its ability to have spectrum auctions, and
Mm-hmm.
I feel like we've just seen so much change in that area in a net positive way, and seeing what is coming out in some of the current policies as we just discussed, I'm a little concerned that we are not going to continue to push forward with spectrum in a really, figuring out how to use it differently. You mentioned on your
Yeah.
podcast, you had with Mary Brown, the idea that we just need to rethink how we're using spectrum and use it in a much, better fashion. Plus the technology is so much better.
Well, I think the best thing about the spectrum pipeline discussion is that there is one,
Right.
because we've if you watch the hearing where Mary was one of the witnesses, there's another witness, Jane Stankiewicz from Intel, who had to explain like about 3 times exactly why there's always going to be a spectrum pipeline, just because of the process that regulators have to go through to identify, and also standards makers. So all of these, 3G, 4G, 5G, those are all different wireless standards, Wi-Fi 5, Wi-Fi 6. And they all begin with identifying some swaths of spectrum that could be used for the next upgrade in the network. And then you come up with use cases, uh, and the use cases and the spectrum bands are kind of intertwined. And then you look at, what the occupancy is of the spectrum. And then you got to look at international considerations. And before any of this turns into a product, companies have to make chips for it. Qualcomm and Intel and Broadcom have got to make chips that can turn the spectrum into a usable network. And so it's a really, even if there was no contention, no battling interest groups, none of that nonsense. If it was just a matter of, pick some spectrum, write a standard for it, build some chips, get some networks stood up, and now you'll have applications. Even if that's all there was to it, that's an extremely lengthy process, whether you're licensed or unlicensed. There are so many moving parts to it.
In
And so
forecasting. Right.
it has to be understood that if we're not allocating, if we haven't identified spectrum today that we can start through the hopper, kind of through the assembly line to become a usable product in the next, few years, there won't be a 6G.
Right.
Um, and so it just has to start. And that means that it turns out, for a long time, we thought the biggest problem with allocating spectrum to a new kind of networking technology or application or use case was getting rid of the incumbents. It turns out that's actually a much easier problem when the incumbent user is motivated properly, they can exit the band, pretty fast. I mean, when it came time to, you probably sat through some of the same talks at the TPI Aspen Forum that I did about C-band and the vagaries of getting the C-band spectrum transferred from the hands of satellite operators to terrestrial 5G networks. And it seemed like it was like a magic, thing that would take forever to do. But, from the time the FCC actually released their report and order authorizing the transfer and authorizing the auction to the first, stood up networks was like less than 2 years.
Wow. Yeah, in government time, that is a miracle.
That's instantaneous. That's like it completed before it started in government time.
Exactly.
And I was looking back on some of the things that you remember the PCAST report that came out during the Obama administration that it was heavily driven by Google and Microsoft and both firms that had a, a really strong bias in favor of unlicensed networks and really not skin in the game in a substantial way.
You mean
And
TV
they
One?
said, well, we can't go with the traditional model where we clear incumbents and auction the spectrum off because it'll just take too long.
Yeah.
And so the thing they proposed is citizens band radio service. It turns out that's all of this happened 12 years ago. And CBRS, I mean, it's starting to be deployed, but it's pretty much a niche product that goes into rural areas where people can't afford the price of conventional, licenses that are nationwide. And we did this whole, C-band thing in like 2 years, and it turns out the biggest delay in that wasn't actually incumbents; it was the FAA.
Oh yeah.
I mean, it was a regulator who, had plenty of opportunity to contribute to the FCC's NPRM, and kind of did it in a token manner. And they raised some issues. The FCC dealt with the issues, and blah blah. It went forward. But yeah, it turns out that's really when you have a motivated incumbent or an incumbent who is just simply not using the spectrum in a substantial way, it doesn't take long.
That's and you
And
you mentioned the
yeah,
altimeters on your other podcast. I thought that was really interesting. I didn't realize they ended up going up to Boulder to kind of have the final say on whether or not it was a problem with interference.
yeah. I mean, I don't know why the NTIA, FAA, and the FCC hadn't been sitting together in a room working on this problem for 2 years before it. You know, as soon as the report and order came out, they should have been doing that. And for some reason, they didn't. And I think part of that had to do with the fact that you had acting administrators at NTIA. There were like four after David Rettle left. There were like four acting administrators. And I don't know. It's some government interagency politics going on where they weren't doing that, and the FAA didn't have any real strong opinions about it because they don't actually fly the planes, and the plane people, well, they relied on their models, and at first it looked like everything was fine, then it wasn't fine, then it was fine again, and I think we're kind of back at the stage where it's all pretty much fine. Although I think there is some last minute issue that just came up where some of the airlines are concerned that maybe the next phase of the rollout may be troublesome for them. But yeah, it really just goes to show you that the knowledge to solve these problems and to come up with accommodations isn't widely distributed. So it's sort of like the future is already here; it's just not evenly distributed. And the people at NTIA and the airlines, and I mean, there's just so many people. It's a big federal government
Well, somebody who
square
likes to
dance.
fly, I want to make sure it's safe. And I've been in a
Yeah,
couple landings lately where I've been glad knowing that I've actually taken the time to look at some of those studies and it's all okay and we landed safely.
yeah. Yeah. And basically the planes are all flown by robots now. I mean, there's a pilot in the cockpit, but I think most of the time, if things are going well, they're just sort of there as a backup for when if the robot fails, then yeah, it's good to have a human pilot there that can step in. But yeah, it's all flown, it's done by robots. But they'll get it all worked out. I mean, it's just a matter of I'd be really surprised if there weren't some 50-year-old altimeters that are still in use that are not going to be resilient when they have signals that are closer than 300 megahertz separation, which is what they actually asked for at one point, to where the total allocation for altimeters would have been 3 times as much as it is for the whole over the air TV system.
Right. Well, I think we get used to all the great advancements and we forget that sometimes things age out. I mean, as somebody who
Yeah,
I get a new phone every year because I want to see what the cool kids are doing.
I think this is actually one of the most poorly understood problems in technology. The fact that when you design a system, you have to actually build in a transition capability so that it can be replaced with a subsequent better system someday.
Yep.
And I think the tendency, and it's just probably human nature, but it certainly is a tendency in policymaking to figure like you're solving the problem with your policy. And then once you solve the problem remains solved forever. But in technology, you solve the problem until the next iteration of the technology. I mean, Internet Protocol had this same problem. I mean, it wasn't it wasn't designed for a smooth transition from IPv4 to IPv6, and yeah, and there's a real good reason why that didn't happen with IPv4 because IPv4 was supposed to be a throwaway system. The whole TCP/IP internet was supposed to be replaced with OSI protocols, Open Systems Interconnection, in the late 80s, and it just didn't happen. I mean, the replacement product didn't arrive in time.
Yeah, it just kept
So we
working.
just so we just stuck with TCP/IP because it worked.
Well, you also the big rollout for IPv6, I think was in 2008, and we had a recession, a huge recession that year. And so we had a lot of people that are like, wait a minute, why am I replacing? Are these still working? Let's, because there was a big equipment change you needed. So that was a really unique kind of
Hmm.
for everybody to get through.
Well, and it was the kind of thing that it didn't really offer. IPv6 doesn't really offer any capabilities that IPv4 doesn't have. It's just that it has more addresses.
Right. I was
And
reading an article the other day
yeah.
that saying that actually the content delivery networks have helped also alleviate any kind of need to immediately migrate as well, because it's just the traffic's flowing differently than they expected when they were just
Hmm.
really pushing IPv6.
Yeah, and it turns out that not every Internet Protocol address needs to be unique among the whole universe of Internet Protocol addresses, right? I mean, these 192 and 10.0 addresses we use on our home networks, they're used by everybody else on home networks, but there's no collision because it's unique within the scope of the network that it's on, but it doesn't have to be global. And when you go global, you go through your network address translator and you get an address that is unique in the whole world, but there's like only one of those for your whole office or your whole home. So um but yeah, why that was a bit of a digression. Oh yeah, so you got to design in some obsolescence
Yeah,
for
but
it.
I learned so much when you digress. I like that. I'm just
Hmm.
glad you guys, you engineers are so smart. You came up with all this stuff.
Well, I mean, what I'm actually
Or-
talking about is a sort of big failure of engineering.
Well, but the
And we still do that. I mean, there are with unlicensed. There's nothing. If you're using an 802.11b Wi-Fi connection, you actually drag down the performance of all of your neighbors.
why is that?
And yeah, because it just the 802.11b signal, our system can't see the signals coming from the later systems. And so it instead of, it's listen before talk, right? and so if you have one of these old timey systems and your neighbor has a 802.11ax or AZ, then your .b system can't see it, so it doesn't know when it should refrain from transmitting and when it's okay.
Oh, I didn't know
'Cause-
that. Hmm.
yeah, yeah, and there aren't a whole lot of those things in use anymore. And there's some features in the later iterations of the protocol that allow systems to warn each other that there's an 11B system on the air. So the new ones can see the old ones, but the old ones can't see the new ones.
Hmm.
And so they have to like go try to work around them. And it'd be kind of better for everybody if, say, if you're in a neighborhood where there are some obsolete nodes, and now I guess nowadays if you have a 802.11g, you're sort of an obsolete node, or where if you just have plain A, you're an obsolete node. It'd be in everybody's interest to replace those with something newer. But there's nobody's in control, right? It's a completely decentralized, unlicensed, uncontrolled system. So as long as you're within the FCC guidelines, you can pretty well do whatever you want. So it makes upgrading a little bit less graceful than it would be if the system had a mechanism designed into it to facilitate upgrades. But that's one of those live and learn things. I mean, if we had it to do all over again, we'd do it different.
And the devices that are still working are working. So there's
Yeah,
not
yeah, right. I mean,
stops working.
and people only upgrade when there's a problem,
Right.
or you just sort of accidentally happen to buy a new computer and it has newer Wi-Fi in it. That's cool.
It is cool.
So yeah, designing for replacement. And so, I mean, clearly, if you were doing altimeters in the 1950s, you weren't thinking about the mobile future and drones and robots. And I mean, unless you're maybe a sci-fi fan, but I mean, it just wasn't part of day-to-day business life. But landing that plane certainly was. So that has to be. They'll have to upgrade the altimeters in some of the old planes, I imagine, and that probably could have been done anytime in the last 50 years and didn't. And so live and learn, and we'll find out whether that's a real serious problem as soon as we get an inventory. It's sort of like how the FCC is continually being hectored because their maps aren't accurate enough.
Yes.
Yeah, well, and the aviation equipment of that is you need an inventory of all the equipment, automated flight equipment that's in all the airplanes and all the helicopters in use today. And I don't know that anyone has that.
Well, I always think those are the planes that eventually get sold to other countries. They're still working. They're just in.
Yeah, like those DC-3s, they still fly all over the third world.
Yeah.
Yeah, haven't been manufactured for like a million years, but yeah,
Somebody
it's a
got parts and they're
workhorse
still
of
flying them. Yeah.
yeah, yeah. I mean, they're built like tractors.
I hadn't thought of that.
Yeah.
Interesting.
Well, it turns out tractors are military equipment.
They just keep working again.
That's how you disable a Russian tank. You hook a Ukrainian tractor up to it and just haul it away.
Going. Speaking of, any thoughts about Starlink and how that's working over there? So they're using unlicensed?
Yeah, it's mostly unlicensed, but it's in a pretty high. It's like 12 gigahertz, so they don't have a whole lot of competing applications. So for all practical purposes, it may as well be licensed because nobody else is trying to use it.
Oh, that's interesting.
And it's also the orientation of the signal because it goes straight up. It's not going to interfere with a terrestrial system that goes like from an antenna on a street light to a car. I mean, it's that's one of the dimensions in which you can pack more applications into a frequency is depending on the orientation of the signal. Seems to be working pretty well.
I'll be curious to see if they give us any kind of after action reports on that. Sort of like when they had the situation with the balloon over Puerto Rico. It just was a needed time and it worked. Wouldn't want to use that all the time, but it was interesting.
Thing about Tesla is they are and Starlink and well, the Elon Musk enterprises, they feel like they're too good to sully their businesses with public relations. So they do a lot of cool stuff that they just never tell anybody about. I mean, their customers know about it, but they don't make much of an effort to share with the world, the great things they did. I mean, maybe at the whenever this situation reaches a satisfactory outcome, maybe they'll share something with us. But yeah, they're real close to the vest.
Yep, that's interesting. Well, Richard, it's been great talking to you and catching up. I always learn a lot.
Yep, yep. Well, I hope it's been helpful.
Yeah, absolutely.
Trying to help people understand that there's an exploding demand for spectrum. Oh, and the thing I didn't even talk about at all is drones. I think drones, like surveillance drones, are going to be a really big thing, even for consumers.
Mhm.
Because when you have security cameras around your residence, um, it's helpful to get you need to and you see an intruder, a bad guy. It's often helpful to have like a really good close up so you can share the picture with the cops,
Yeah.
right? And so you need a high resolution image, and oftentimes I think the best way to take that would be to combine your security cameras that are in fixed locations with a drone mounted camera that can get real close and get a really good picture.
Would they be
Um,
autonomous drones? Would they automatically go into action, or would you be working with them inside the house? Because I'm not
no,
sure
I think it would be triggered by the security cameras, but there's a motion detector in the security cameras
that
that
would.
essentially enables and disables recording. And so you can like launch a drone and say, go look for motion around this particular camera, and it'll find the moving object, and which is probably going to be the bad guy. So this is my prediction for the app, the killer app for 6G is going to be
Surveillance drone.
surveillance drones, residential surveillance drones.
I think that there's a Netflix story in there for you somewhere. A lot of footage.
Yeah. Okay. And so yeah, to get there, all we need to do is get this spectrum pipeline squared away. And as you said, the FCC's auction authority needs to be reauthorized,
Absolutely.
and that shouldn't take long. I mean, it just takes a clean little one-page bill to get through Congress to reauthorize it. Just take the last one and change the date. So blah blah. There we are.
Yes.
But yeah, they need to do that. I guess there's so many other issues occupying their time. I don't know. I'm not going to make excuses for the fact that it hadn't been done, but it needs to be done.
Well, let's hope that it doesn't get politicized because we all need that spectrum.
Absolutely. And you and when you stop it's like the supply chain for all the goods. When you disrupt the supply chain, it takes a long time to get it restarted.
Yes.
And
Yeah.
you've got all those. You've seen the pictures of all those ships in the harbor at Long Beach that that can't dock. I mean, we don't want that kind of scenario, with Spectrum.
Yes. Yeah. It's a good visual because sometimes that's a problem because you can't visually see it at that level. People don't understand how important it is to get it all into a long tail process.
Mm-hmm. There you go. All right, folks. There you have it. This has been High Tech Forum podcast with Shane Tews, and we do these things on a fairly irregular basis. Try to do it at least once a month, sometimes more frequently. When there's a really hot issue burning, I might do one a week. Don't think I've ever done it more frequently than that. And you can subscribe to the podcast in all the usual places. And like every other podcaster in the world, I want you to react to it with either likes and or dislikes or whatever, because the killer is to be ignored. So anyway, Shane, pleasure to have you back.
Richard,
Hope
thanks
it
for
won't
having
be
me.
won't be as long next time,
Okay.
and keep up the good work.
All right. Stay in touch, my friend.
All right.